what we're going to be looking at here is a demonstration to show dynamic equilibrium. In this cylinder here, we've got a brown gas and actually a colourless gas. The brown gas is NO2. So first I want to show you how that brown gas was made, which is just a reaction between concentrated nitric acid and copper. And it's not just a normal acid-metal reaction, it is what we call an oxidation-reduction reaction as well. So it doesn't just make, well, it actually doesn't make hydrogen gas at all. What it makes instead is NO2. And we can tell that it's different by the colour. So I'll show you that now. You don't need a lot of copper to do this. And if we see in there it's going a bit of a brown colour there. Right, the reason we're doing this in a fume cupboard is that the gas is really poisonous. So we don't really want a lot of it in our lungs. I'm going to cap that, so I'll put a lid on that so that I can turn the fan off. Okay, I still have to talk over that fan for a wee while. So, once I make that gas, it can escape into the environment and that's it. It doesn't do anything else. But if I capture that gas and put it in a closed environment, so something that it can't escape from, then we get an equilibrium occurring. And that's what we can see in this vial here. Okay? So what we've got is two NO2 molecules reacting to make this N2O4. The NO2 is brown and the N2O4 is colourless. And that's what we've got in our closed system here. Now, because they're all gases, we can play with this equilibrium. But at the moment, while it's sitting there at pretty much the same pressure as air pressure, we've got a situation where the forward reaction goes at the same rate as the backwards reaction. It looks like nothing is changing. It looks like nothing is happening. But really what's happening is we've got the forward reaction happening and the backwards reaction happening at the same time at the same rate. I can change that by changing the conditions. If I change the conditions in an equilibrium, then a thing called Le Chatelier's principle applies, and that is where the equilibrium will either favour the backwards reaction for a wee while, or favour the forwards reaction for a wee while, to re-establish equilibrium, to re-establish a new equilibrium. One of the best ways to do this with things that are all gases is to play with the pressure. If I apply more pressure to this, the particles will get closer together, which makes it look darker. But if I hold that pressure in, that colour will start to go towards the one with fewer gas particles. And if I have a look here in my equation, there's two gas particles as reagents and one gas particle as a product. So it's going to favour the side that has got fewer gas particles if I increase the pressure. Now remember, it will get darker first because the particles are going to be closer together. So let's have a look at that first on the video and then I'll show you. So I hold it in and it goes darker first of all, and now it's starting to fade again. I'll bring it out and show you that again. Like in front of me, you can see it. It will go darker first, but now you can see it starting to fade. Only subtle, okay, but it does fade. It's probably easier to show you the other way, where it will go lighter and then start to darken. If I decrease the pressure, so pull back on the syringe, it goes lighter, I hold it out there, the colour slightly darkens. Again, I've done that in front of the video, now I'll show you that here. Goes a little bit lighter, now it's starting to go darker. That's not particularly easy to see, is it? Okay, well, one of these reactions is exothermic and one is endothermic. If the reaction one way is exothermic, the other one must be endo. Okay? So I'm going to use hot water and cold water to show changes to the equilibrium as well. Okay, the one farthest away from you is iced water, so that's on the left hand side in the video. The one nearest you, so the right hand side, is about probably 40 degrees, so relatively warm water. I'm going to put the syringe into the warm water and just take note of that colour and we'll see if it changes. Now of course, being warm water, it's increasing the reaction rate, it's increasing in both directions. So we notice, oh, it's trying to change the pressure quite dramatically. It's pushing out. So what does that suggest it's making? More gas particles or fewer gas particles? More. And sure enough, it's quite a lot darker now, isn't it? Okay, let's swap these over so you can see it in iced water. So what would we expect to happen in iced water? Go lighter. What do you think it'll do to the syringe? Pull it in. Let's see if we're right. I think already you can see it fading in colour straight away. The ice water does this a little bit more dramatically for colour, but not so more dramatically for the pressure change. And we can see that it has indeed gone a lot lighter. So this is Le Chatelier's principle. In here we have a dynamic equilibrium. Forward reaction and backwards reaction happening at the same rate, so we don't observe a change. But if we do change any of the conditions, pressure, temperature, also concentration or amount of reactants or products, then the equilibrium has to change or shift its position either towards the reagents or the products to overcome what we've tried to do to it. And that's Le Chatelier's principle. So the last thing we need to do is make a conclusion. When we put it in iced water, the colour faded, so we went towards N2O4. That means the forward reaction is what? Exothermic or endothermic? I've cooled it down, it's going to try and what? Heat it up or cool it down more? It's going to try and heat it up to overcome what I've done. I've tried to change something, it wants to stop me doing that. So by cooling it down, it wants to heat itself up. How can it do that? The exothermic way will create heat energy. So that means the forward reaction must be exothermic, so the reverse reaction must be fantastic. That's basically a summary of equilibrium, of the entire chapter that we're going to be doing for the next